Hello, everybody. Welcome to the last session of PyData. We have Hendrik Heuer. He's in University of Bremen, working with Institute of Information Management, and he's going to talk about data science for digital humanities. So please give him a round of applause.
Thank you very much. I hope, can you hear me? Yeah. Thank you for the introduction, and thank you for sticking with me and coming here. I'm going to talk about data science for digital humanities, but also a bit about computational social science. I use these terms somewhat interchangeably. As already said, I'm with the University of Bremen. I'm doing my PhD there, studied in Stockholm and Helsinki. I have a website if you want to find out more. But let's start with a nice example. I don't know who of you has seen this example of Target. So this is a US shop, and they did figure out that the woman was pregnant before she realized it herself. So they basically look at her buying history and analyze that, and then they try to send her targeted ads. So they give her coupons for the family. And in this case, she didn't know she was pregnant, but she was already getting ads for pregnant women. And that was huge. That was a huge outrage for the family. But you can also think about the consequences in a culture where teen pregnancy might just not be okay because the woman is not married. And you don't want to be the one who's outed by Target or is outed by Edeka that you're pregnant to your parents. You probably want to tell them yourself. And I like this example because it just shows that really simple data can give away a lot of really important patterns. Another thing, and you've probably seen this, is sentiment analysis. This has huge commercial appeal because if you're Amazon and you want to automatically decide whether people do like a camera or they don't like a camera, then it's really, really helpful for you to have sentences and be able to say whether they're positive or negative. And the way this connects to digital humanities and why I'm bringing this up is that you can, of course, also do it on political debates. So here, a company from Sweden called GoverGuy, who's providing an API, was mining a lot of data that's published on Sweden in newspapers, in blogs, on Twitter, and then they're basically aggregating how the people in Sweden feel about refugees. So this allows really exciting research on a large scale because you can basically look at every tweet, you can look at everything and then analyze it. It's also reductionistic, so we have to use it sensibly. In the abstract to this talk, I promise that analyzing millions of images and enormous text sources using machine learning is simple and straightforward in the Python ecosystem, and I hope I can convince you. There was a lot of talk on machine learning here. I usually love to bring up this picture because that's kind of the essence, right? You have two classes and you want to basically classify them, and you're just trying to draw this line between the two classes. So that's the essence of machine learning. It's basically the cover of one of the nice machine learning books. And you probably heard this, that data science is just statistics on a Mac. But I do like the definition that a data scientist is someone who's better at statistics than any software engineer and better at software engineering than any statistician. And that's the definition I'm going with. Just a quick, of course, overview. In the academic world, there's already a publication in 2001 by Cleveland on data science, and he basically saw it as an enlargement of statistics. And the important thing about data science is this learning from data. And you've probably also seen it called the sexiest job of the 21st century. But I want to show how this is relevant and how this is useful for scientists in the social sciences, in the humanities. And a really famous example is this by Adamick and Glantz, who famously visualized the divide in the political blogosphere of the 2004 US election. And for that, they compared 40 blogs over 2 months, and they visualize who is linking to whom. And they kind of showed that conservative blogs, they tend to link to conservative blogs, and liberal blogs tend to link to liberal blogs. And there's not really much exchange between the two of them. And the nice thing is really that it's one of these things that everybody kind of had a feeling that this was happening. You know, you probably heard about the echo chamber, you probably heard about filter bubbles, but this is super obvious and very, very nicely visualized and makes this problem very, very clear. I really like this notion that computer science or informatics, as we call in German, is just mathematics plus X. So there's not really much computer science in itself. It's always in relation to something. It's always applied to something. It can be applied to biology. It can be applied to various business cases. And that makes computer science and informatics fundamentally postmodern. At the same time, computational is this nice new paradigm. And of course, this goes nicely with this increase in volume, variety, and velocity of data, what we usually call big data. And I like to give this to my students as a thought experiment, because many people here probably are really good at coding in that they're good at explicitly formulating instructions, working with loops, working with conditions. But if you were tasked with writing an explicit program for that, it will be very, very hard, because it's really hard to tell what makes a 6 a 6. It gets really philosophical. But of course, you can just learn it from the data. You can just infer it from the data. And for me, doing data science is always a bit like playing Lego, because we have these nice tools. We have natural language processing toolkit. We have Word2Vec and SpaCy. We have visualization tools. We have topic modeling tools. I'm going to talk in a bit more detail about topic modeling, because that allows really, really exciting research in the humanities. And then, of course, scikit-learn was mentioned many, many times, Keras, TensorFlow, Theano, Caffe. So this is a really nice overview, and you're basically just stacking together. It's really like playing Lego. In the abstract, there was also this example that you should imagine a journalist who wants to cross-reference the names on the guest list of a parliament with online information about lobbyists. And then the goal was to identify which party in this parliament would meet which company. And this is actually from the keynote of PyCon Sweden in 2014, but I like it very, very much. And in this example, Helena Bengtsson, who at that time worked at Sveriges Television, which is the Swedish ARD, who's now at The Guardian, she looked at the lobbying in the Swedish parliament. And she really just naively asked the people in the parliament, basically the people at the front desk, if she could get the list of visitors. And they gave it to her, and this is actually the list. So you see who was visiting, and you can also see who they're visiting, but you don't know who they're lobbying for. It's just their first names. So she made this very, very simple program, but she has this nice hacker attitude, and she just combined it in a very nice way, where she basically took this Excel list of visitors of the Swedish parliament, and she extracted the names of the visitors, and then she found the lobbying agency the visitor is working for. And at the same time, she got a list of Swedish companies, and she found the lobbying agency that was employed by the company. And it's really like a funny situation, because on the one hand, these lobbying agencies are very, very proud of the people they employ, because they went to good schools and they're somewhat famous. And at the same time, it's really important for them to show they're working for famous people, because they're references. So the task here was to find them, and this is really just simple data scraping, and I'm pretty sure that everybody could do this here. But using that and then looking at the intersection set of these two data sources, she could expose lobbying. Now, the Swedes are nice people, but they're not stupid. So at some point, they decided maybe it's not good to give them the entire list of visitors to the Swedish parliament. They made it a bit harder, and they basically said, you have to come there, and you can do one request per day by mail in a letter, and then we reply in written form to make it really make her life a bit harder. But thanks to machine learning, thanks to the Python ecosystem, and her hacking skills, she then basically added optical character recognition of this printed list of the visitors of the Swedish parliament, and then her script could work again. Another nice example, which kind of shows the power of using computational methods in this humanities and social science context are these small world experiments. And it goes back to this idea that it's about looking at the average path length for social networks of people. And you probably heard about, some of you have heard about this idea of 6 degrees of separation. And it means that all living things and beings and everything else in the world is just 6 or fewer steps away from each other, so that a chain of a friend can be made to connect anybody. Basically saying, my professor knows politicians in Bremen, they know politicians in Berlin, and that's basically my path to Angela Merkel, and that's how well I know her. And this has been studied in 1929 already. There's also a famous study by Milgram of the Milgram experiment, if some of you know. But where it got really interesting to us in this particular case is when Duncan Watt in 2001, at the time he was a professor at Columbia University, attempted to recreate this experiment. And he basically had an email message, that was the package, and he sent that to 48,000 senders in 19 different targets. And he found that the average, though not maximum, so there were longer paths, but the average number of intermediaries on these paths was actually 6. So he could show that on a large scale with 50,000 messages that people are actually that well connected. Then in 2007 there was another study by Jure Lesovsky and Eric Horowitz, and they examined a data set of instant messages that was composed of 30 billion conversations with 240 million people. And they again found that the average path length, and in this particular case it was on Microsoft Messenger, was 6 again. So as you can see, it shows 2 things. It's research that has been done, but you can now do it maybe simpler, but also at a much larger scale. You can have millions of people, billions of conversations, and you can easily crawl them. So who of you actually had heard the term digital humanities before? Actually, yeah, I'm surprised. So the humanities are the academic discipline that study the expressions of the human mind. We call it Geisteswissenschaften in German. And digital humanities is then meant as the intersection of the humanities as we know them and computer science. Because this opens up new research methods. And it creates a new environment in which we can try out new things. And it's really interesting because on the one hand, we have this unprecedented amount of data that's born digital, you know, like Facebook messages. They always have been digital. And on the other hand, we're digitizing a lot of stuff. You know, if you look at Google Books, a lot of these books are available. And the hope is, of course, that this can help us enhance our understanding of individuals and collectives. One of the first times this was done, it's quite surprising, was in 1948. So these scientific collaborations between computer science and the humanities, they're again nothing new. And there was a Jesuit and theologian called Robert Buser, and he did approach Thomas J. Watson, who was the founder, or is the founder of IBM. And he wanted help to index the work of Thomas Aquinas. So they basically did this Index Domesticus, which is considered to be the first electronic text project in the humanities. And it's a really significant early employment of computer resources in the humanities. One thing that's really, really nice and very, very helpful is this so-called topic modeling. And I know there was a talk and a tutorial on that, but just a quick repetition to get everybody on the same page. So there's a technique called latent Dirichlet allocation, and the idea is to represent documents as mixtures of topics. So basically say every document is a probability distribution or has a probability distribution of having a certain topic or talking about a topic. So each document is a probability distribution over topics, and each topic is a probability distribution over words. And you can see that here. So you have the words like gene, DNA, and genetic. And if you have enough data, even in an unsupervised fashion, you kind of see that they have something to do with each other. They co-occur, they're close to each other. And if you do that for many, many topics in an iterative fashion, you get very, very different words that represent a topic. And you can then also show which document is associated with which topic. And to make this much more visual, I have this very, very small toy example for latent Dirichlet allocation. And we just pretend we have these 5 sentences. And the first one would be, I ate a banana and spinach smoothie for breakfast. The third one, for instance, chinchillas and kittens are cute. And the fifth one, look at this cute hamster munching on a piece of broccoli. And you probably all would agree that there are 2 main topics in these sentences. One topic would be food, and the other one would be cute animals. So this is basically this probability distribution over the corpus. So we can see, okay, there are like words that are somewhat connected because they talk about the same things and they occur in some sentences. So you can say, okay, the first 2 sentences are about food, the third and fourth about cute animals. And this is really interesting, and that makes it so powerful. The last sentence is mostly or much more about food and somewhat about animals, because it has munching and broccoli. That makes it more about food. And we all can also then say, okay, topic A consists of the words broccoli, bananas, breakfast, and munching, but we can also say of how much it basically consists of these topics, and the same for topic B. And this was then used to analyze journalism. So there's a paper called Massive Scale Automated Analysis of News Content, and what they did is they took this huge corpus with 2.5 million articles from about 500 English language news outlets. So that's basically everything the New York Times has ever published, everything Reuters is publishing. And they used this latent Dirichlet allocation to annotate it into 15 different topic areas. And then they compared the news outlets and the topics in regards to the readability, which you can measure, the subjectivity, and gender imbalances. So linguistic subjectivity, for instance, for readability, there are many scores, and you can just basically look for readability scores, and you find them, and they're from the 70s, but they basically tell you, okay, somebody has to be at this school grade to understand this text approximately. Linguistic subjectivity, for that, they basically looked at the adjectives and the amount of adjectives in the sentences. Then they had a dictionary where they wrote down, for instance, happy is a very positive word, sad is a very negative word, and then they combined that. And here then they applied it to a variety of newspapers. So in the simplest case, they just looked at these 15 topics that they derived from the data, and then they, using a mathematical method, projected down this information to make similar newspapers being close to each other. And what you clearly can see is that there's a cluster of quality newspapers. Then there's the Wall Street Journal being completely different from anybody else, because probably it's only talking about politics. And you have a lot of other newspapers. You can then also look at how these newspapers do compare in terms of readability. Are they easy to read? Are they hard to read? And this linguistic subjectivity, which is based on adjectives and how we basically assign their happiness, their valency. And you can see that these tabloids, like the Sun and the Daily Mirror, they're very, very easily readable, and they're pretty subjective. They have a lot of adjectives. The Wall Street Journal, again, being not so readable, but also not being quite as unreadable as something like The Guardian, but the least subjective. And you can also do it for topics. So you can say that articles about business and politics, they're very hard to read, and they're also not that subjective. Whereas something about fashion has a lot of adjectives, which of course makes sense, or something like sports is very easily readable. And you can not only do that for newspapers, of course, you can apply that to any kind of text source. So this is another example called macro analysis. by researchers from North America, which basically use these digital methods for literary history. So Jockers is the one who wrote the book. And he showed that factors such as the gender of the author, the nationality, but also the date of publication for a novel does affect the choice of literary themes in novels. So for this, they used these topics from the topic modeling, and they're not perfect, right? It's just a probabilistic model to look at similarities. It's a bit like word2vec. So you try to learn in an unsupervised fashion from the data. So it can't be perfect, but it gives you some insight. And they cleaned it up, and then they identified and extracted hundreds of topics from a corpus of 3,346 works of the 19th century British, Irish, and American fiction. And these are entire books. So 3,300 books. It's really hard to read that many books, let alone annotate them for their topics. But again, using data science, using these kind of methods, they could conduct this analysis. So here are examples for the topics. So for instance, on the bottom right, you see this big cluster connected to education. So knowledge is really big. Education, pupils, study, learning, or the one on the top right connected to family and mostly nieces and nephews. So basically the word cloud also takes the word count into account. So it's really exciting and makes life a lot easier. But on the other hand, it's of course not perfect. And this is a picture of the Gezi protest, where they basically did an analysis on Twitter on the usage of the hashtag connected to Gezi. And if you looked at this, you see that if you look at the data, at the 3rd of June, the usage of the hashtag drops drastically. Right? Less and less people are using this hashtag, and one might conclude that the protest died down around that time. But what they did, and it's actually the wrong citation, I'm sorry about that, but the online ethnography revealed the opposite. The protest did not die down. The protest became the story, the dominant story. So everybody who was tweeting about the Gezi protest, that was all they were talking about. So they just didn't need the hashtag. But just from looking at the data, just from taking this quantitative perspective, you would have never guessed this. And it kind of motivates that it's important to combine quantitative methods like these with qualitative methods, that is, talking to people. Because what they did is they basically reached out to these Twitter users and asked them, what happened? Did it die down on the 3rd? Another problem connected to big data and the like is this famous example of the Google flu trends. So the flu kills 500,000 people a year. So it's a really good idea if you say, okay, we can predict whether the flu will hit a town, whether there will be a flu epidemic in Berlin, just by looking at search engine query data. And these people published in Nature, which is super famous, right? That's where basically Watson and Crick published about the structure of DNA. And they said, okay, we can predict this. The problem is they couldn't. Because after 2 or 3 years, there was this issue discussed in Science of big data hybrids. Because this model about Google flu predicted more than double the proportion of doctoral visits than actually happened. And there were 2 main reasons for that. So there's this big data hybris and the algorithmic dynamics. So algorithmic dynamics means that the Google search engine is always changing. So engineers are doing changes every day to improve it as a commercial service. But this did basically create feedback loops and led to huge overfitting in the algorithm. So now, one other thing I would like to talk quickly about computer vision and how that can be used in a context of digital humanities and computational social science. And who of you has seen these ImageNet competitions? Who of you has heard about that? Okay, so almost half. The idea is basically to find objects in images And you do that with 1,000 categories. And this is really diverse. It goes from leopard to cherry to container chip. And what makes this special is that you have 1.2 million images for training. And you can reuse these networks. So it takes a lot of time to train them, and you need a bunch of GPUs for that. But you can basically fine-tune that. You can do this kind of transfer learning. And there were some talks talking about this already, to basically use them for your purposes. I'm just skipping that one. But if you have this network that is basically trained on ImageNet, and it's trained on predicting these thousands of categories, you have vectors representing the image, right? You have something and you put something through your neural network, and at the end of it, you basically have this one layer, the one before the neural network makes the decision what class it will predict. And this is usually sometimes a 4096-dimensional vector that's a representation of what's in the image. And you can then use that to position different images on this map. And you see that similar objects end up being close to each other and end up being next to each other. And this dynamic you can basically hack and you can use for your own research. In the simplest case, you can even have very, very few images, for instance, of cats and dogs, and then use these features to make the decision whether this is a cat or whether this is a dog. But what you can also do is to apply this to paintings, right? If you would train the same, like a similar network on paintings, you would be able to find similar paintings and find paintings that show similar things very, very easily. And again, you could do this with millions of paintings without, you only need computational power and time. And what's interesting is that you've probably all seen this by now. So these semantic relations in word2vec, there's one dimension representing plural, and there's another one that could be named as like the gender, like the femaleness. This also holds true for generative models in terms of meaning that you can basically take a picture and then apply a vector and make this person smile. So this is a probability distribution that's capturing a face, and you add a vector and make somebody smile. Or you turn somebody in a female version, you turn somebody in an old version. But you can basically do that because it's a generative model that captures something about faces, and then you basically take a picture of me when I'm young, of me when I'm not smiling, and when I'm smiling, and you take that vector and you apply it. And this is really, really exciting because it will make these things Roloff was talking about possible and even more powerful. So this is an example from Berkeley where they basically have you sketch something simple. You just draw a line here, you draw a line there, and draw a line there. And then the neural network is kind of sampling from this probability distribution that it learned on millions and millions of images, and it will generate nice mountains with just like very, very little user input. Because it learns to represent structure. In some cases, it learns to represent what a face is, or in this case, it learns what kind of images you gave it. So if you want to get into this, I have 3 recommendations for books. The Cathy O'Neill, Rachel Shutt book is very nice. It was one of the first books on data science, mostly conceptual. Gives you a very nice overview about defining data science, because everybody's talking about it, but it's relatively new, and we as a community don't really have a good idea what is data science and what's not. So I really like that as a start. If you want to get into the programming aspects, it's a really good introduction to scikit-learn in practice, but also machine learning in theory. It was written by one of the creators of scikit-learn. And then a bit more PhD level, the book on deep learning by Bengio, Courville, and Goodfellow. I think it's the best book on deep learning. and it's surprisingly readable. It even goes through the mathematics, and I think you can still look at it for free online before you buy it. And with that, I'm happy to take your questions. Thank you again.
Are there any questions?
Can you comment a little bit on the slides that you had skipped?
Oh, okay. Yeah, sure. Now that we have the time, it's a good
That was
point.
about brain, right?
Yeah, so this is from a TED Talk by Joshua Bengio, and it's about neural networks, and it's basically meant to give you a nice intuition of how it works. Because if you apply this to images, on the lowest level, it learns filters, which are maybe like a horizontal line filter or a vertical line. So this is like mostly edge detection. And on the next layer of this neural network, it's recombining these filters, right? Because it gets these neurons as input, and it's combining them, getting a bit more geometrical shapes. And it's going up and up. I'm a bit skeptical about this actually capturing meaning. I think it's really good at capturing probability distributions for sure. But what's exciting is that these lower filters, they correspond to the brain. So this is from, I'm not a cognitive scientist, but this does correspond to what we know about the brain. And there are these like experiments where they did really weird things to the brains of cats to put stuff in there to see that we actually have these kind of filters.
Hi, so you're in like the area of digital humanities, and you say that you're kind of more on the computational social science side. But like one thing I was wondering is just because you're on the edge of sort of like two disciplines, like computer science and then social science, do you ever find any like pushback between the two disciplines? And like when you want to publish, do you find it difficult to kind of select venues, or do you find there's more venues appearing for this intersectional sort of research that's happening?
Yeah, thank you for the question. The funny thing is actually that my research topic, my PhD, is in human-computer interaction, and it's about trust in machine learning. And this emerged from this. So we've been building tools for geographers, for sociologists, to visualize things, not even machine learning at the time, but just to visualize this. And then they're like, yeah, this looks cool, but. And then there's a long pause, you know, because they don't really know how to use it for themselves, but they're also not really sure what they see. So I really want to help them to understand these kind of things. And so I'm much more oriented at these traditional venues, but there's more and more coming. There's a Digital Humanities conference. There's also a wonderful summer school in Oxford, which is a bit pricey. But so I first heard about Digital Humanities when I was studying in Helsinki, and the professor went to the summer school and he recommended it. It's very nice, yeah.
Thanks for the presentation. Quite an obvious question, but why do you think that it has taken so long for programming and more statistical, more hard skills to penetrate some humanities schools? And I know that probably if we take a Northern European humanities school, you're going to tell me that they've got actually the best stats teachers and the best Python teachers, but I come from Southern Europe, and there's kind of this very clear divide between soft skills go to one side, hard skills go to another, and they never quite meet.
I think it's always individuals who have been doing it, and they have been doing it forever, like this monk who wanted to study these texts, right? I think now it kind of become popular and more mainstream, and I think a lot of people, like the majority of people in these social science departments actually see the benefit now. I think there were always pioneers who understood it and who wanted to do this everywhere, in Southern Europe as well as in Northern Europe.
When you are showing the layers, right, of abstraction, connecting with Andrew Ng's, lectures and so on. Now we have the classification of the images, right, and inference of similar images. Do you know of any things that, like, when any attempts to classify the four-dimensional events with a time dimension? So, like, let's say a video that in which certain things happen, like maybe parts of the movies. In the movie, maybe some actor goes and falls down the cliff, and that's one of the events, right? Yeah, that. When you think about, I mean.
Sorry, now I'm back because I was fiddling with it. No, I have plenty of friends. Plenty of friends in multimedia, and there is a conference called ACM Multimedia, and they have these LSTMs. So it's basically a mixture of LSTMs and CNNs, where you can actually do this kind of analysis and figure out in videos what actions are taking place and this kind of research. So there's really active and a lot of advancement in the last years in that.
I see. Do you know of, or have ever heard of intelligent advisors which would basically collect information that, let's say, with cameras that you're experiencing over your life and recommend, or predict what kind of things are going to happen in what you should do?
No, I have not. I can give that back to the audience. Maybe somebody who knows can come back to you. And with that, I give up the stage. Thank you very much.
Okay, thanks.